Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to keep up to date with the Flat Earth Debate. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they are live. There's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show. And one last time, if you're new to the channel or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to keep up to date with the Flat Earth Debate. Now we are joined by Adam Meakin, Righteous Force and 10th Man in G+, together with a whole bunch of people in Discord, so welcome one and all.
Hello, hello, hello.
Good
Afternoon.
Good morning.
Hello.
Hello, Scratchy Mike Discord crew. Good to have you all. Any signs of physical Earth curve edges, formerly known as a geometric horizon or, quote, Earth curve?
Not from San Diego Airport.
Only in CGI. Found a lot there, but nope.
Only in CGI.
Morning, guys.
Hey, Chocolate, good to have you. Hey, Arwen, good to have you also.
Oh, hey, Choco.
No way.
Adam, the legend.
I'm going to do it.
Going on, guys.
I meant to do this at the beginning of the show. I just forgot. So there's been several new members that have joined Nathan Oakley channel. So we've got Udada, who's joined as a penguin, and scroll. J Mel's 24, who's joined as a unicorn. Tina Baker, who's one of my patrons, who's joined as a unicorn also, and 787GENX, which is Michael. He's a long-standing contributor to me. He's probably one of my first contributors. Thank you very much indeed for joining as a lion. That's Michael, Tina, Jay, and Udada. Thank you very much indeed. I think the reason for that is because the Uncut and After show goes out now immediately after the live show finishes. So if you do want to watch immediately and you're a channel member, I tend to publish the Uncut and After show on the second channel with a delay, so you'll see it with a 24-hour countdown. But if you did want to watch it immediately and you are a channel member, you can. Moving on, housekeeping wise, any evidence of axial rotation of the Earth-based variety?
No.
No.
Nottingham.
No. Any evidence of the distance to the sun?
Come on, Arwen.
It's right over there.
Yeah, I can see it too. Nice clear day. Any evidence of the distance to the sun?
Nathan, they don't know how to measure geometric horizons that don't exist. So how are they going to give us that?
I don't know. Why would you need the horizon in the first instance to measure something like the sun?
What are you talking about? They
It's not really.
Calculate it. All right. No, I'm going to need it measured.
It's a lot clearer day here than the last time I was on. And it looks a bit further away, the sun, today. So I can definitely say it's still more than 1.5 miles away, because it's definitely further away than Sainsbury's.
More than 1.5 miles away. I've got a photo in the old reel, of course. Nice new shiny reel, doesn't have it. Of a picture that I took 3 years ago, where I've got the sun in front of a tree that's less than 100 yards away.
What?
You heard. There's a tree. I can see it from here right now. And I've got a picture of the sun in front of that tree. Just the way it looked. It looked less than 100 yards away in that image. Because the tree was behind it.
I think that might have just been the halo that kind of like shone over.
It was the sun. I don't know what you want me to say. I've got a picture of the sun in front of a tree that's only 100 yards away, probably less. And I published it because I thought it was interesting. And there was one virtually unknown globehead troll with a channel that was actually putting out videos that picked up on it and went, look, Nathan proves the nonsense of people asserting that the clouds are behind the sun with a tree behind the sun, and it's right in the foreground. And I'm like, yeah, I thought that was interesting too. But no one picked up on it. It rolled by on the old reel on every show. No one ever mentioned it.
Maybe because it's just a beautiful picture.
It is a beautiful picture. It's right out my window. That's my view. It is. It's, got trees. Admittedly, there's a school full of kids some parts of the day that are screaming their heads off in between those trees, but you can't see them. But nevertheless, you can hear them, little sods. I mean, the beautiful little children.
No one commented on it because they didn't want to go out on a limb.
I love it. Boom, boom. But anyway, we haven't got it to scroll through and find it now to discuss it. Go on, Neil.
There's people that swear by the clouds being in front of the sun pictures. I mean, the sun in front of the clouds.
Yeah, I know. That was, again, partially why I put it out there. There's a lot of nonsense asserted from the flat earth side of this argument. More stuff moving around my lounge unexpectedly, poltergeist. I put it out because there's a lot of flat earthers that will assert nonsense, especially about celestial objects. And you're like, how do you know? Well, because that's how it makes sense on my model, is normally the answer you get. Well, my model, the sun's right in front of that tree outside my window. Anyway, Adam, anything to add as it was your point?
I think awake souls is the thing that springs to mind.
Awake souls? He's the guy that constantly calls people Satan.
Yeah. He didn't believe his model. But the spawn of Beelzebub.
Shouldn't he be out, finger pointing and claiming people are transsexual when they're not? Isn't that his bag?
No, he thinks I think with Awake Souls, he thinks more like he's literally in hell and everybody is demons but him. That's
I see.
Kind of almost what it comes down to.
He's still going?
I don't know. I never used to watch him, but I used to watch Tim Osman pointing out really weird things that he'd done. Let's move on with housekeeping.
Sorry. It was just a flashback, mate. I'm sorry.
Yeah, that's what I got.
Just...
Soon as I was like, weird things that he'd done, Tim Osman's described them. The things that he'd done went through my mind. I'm like, do I want to discuss any of this? No.
maybe Awake Souls just says things on the fly.
Let's say his name a few more times. We might garner him a few subscribers, right? Moving on. Any scientific evidence of gravity?
Nah.
Not
Nope.
scientific.
CGI evidence.
CGI evidence for gravity? Oh, I suppose
Yeah,
you've got
the G
pictures
and-
of the bending
the
space-time
G.
fabric with
No,
the
no,
little
no.
squares.
You're thinking of descriptive evidence.
No, the G in CGI.
That's a big G. Oh, right.
She just got that. It took a couple of seconds. Moving on. Any single viable hypothesis from any of the fields of astronomy, cosmology, or astrophysics?
Possible.
Well, they could potentially, but yeah, all the things that they speculate about are so far out of reach, they'll never get to actually physically confirming it. But in
So it's impossible.
theory, it could be possible. If any of it would be right, which it isn't.
Well, the question is scientific evidence.
Oh, okay.
No, the standard's even lower. It's not even asking for scientific evidence. A single viable hypothesis isn't asking for scientific evidence. It's the lower standard. So even what you're asking for, or what Quantum Eraser has phrased, very cleverly so, it's actually within within their capabilities. So a hypothesis is also abstract. So what I mean by that is, until you actually perform an experiment and the outcome is what you're classing here, that's the scientific evidence, the outcome of the experimentation. But we're not even asking for that. We're asking for the conceptual part, your supposition of what will cause an effect that they've observed. So they can definitely get to step one, they can observe phenomena. Now all we're asking for is a viable hypothesis. That's a supposition, not anything actualized. So we're not saying give us scientific evidence from any of those fields. They're definitely not going to get that. But we're not even asking for that. We're asking for a viable hypothesis. So it's an even lower standard, 10th man.
Okay, somebody's spamming the chat a lot.
With nuclear signs, saying Coronawin virus. I think they just wanted a shout out. Please don't spam the chat anymore. You got a shout out. Coronawin. Is that how you say that? Coronawin. How am I saying it? Coronawin. Coronawin virus?
No, just stop.
Stop.
Coronawin virus.
Say it again. Coronawin.
Is it?
Yeah, that's clever.
Yeah, I thought that was quite clever. I haven't even timed him out for spamming. He stopped, so he knows he's got a laugh.
Coronawin?
Here we go. Coronawin. That's it. Coronawin. That's it. Coronawin virus.
Covwin 19.
Owen, you're a source of inspiration, man.
Covwin 19.
You see that one, Nathan?
That's great. I love these wins.
You should write these down, Owen. You know, in 20 years' time.
I'm crying here. I haven't even got through the housekeeping yet. Stop spamming the chat. Especially not when we've done housekeeping yet.
19. Hello, can you hear me?
Hey, Babs.
What's up,
Hey,
man?
how's it going? Yeah, so the Globers seem to think that masses can't accelerate on their own without external forces being applied to them. And this is all based on Newtonian laws of motion, where mass times acceleration is equal to force.
Force. I mean, recently we've been talking about the hydrological cycles. So obviously you input energy into a puddle and it changes into gas and then works its way up. But is that putting a force into it? It's putting energy into it, but is that classified as putting a force into it to make it go up?
Well, according to them, a force is equal to a mass that's accelerating. So
these are Newtonian principles, though, right?
Yeah, those are Newtonian
principles.
Right.
The laws of Newton were not right. Richard Feynman.
I've actually heard you say that before.
No, not me. Hell no. I'm not taking credit for that. That's Richard Feynman, not me.
He's the one that said they were wrong?
Correct. Well, no, he didn't say they were wrong. He said they were not right. Well,
isn't that what wrong means?
I'm just quoting him verbatim rather than changing it and paraphrasing it, that's all.
Right. Now, is this a little bit too much to ask for right now, but do you have a citation for that? Because I might need that for later on today.
Just type it into Google. I'll just use their standard. No, I haven't.
Right.
I could try to find it for you and get it to you a little bit later. I'm at work now.
Yeah, just send me a DM or something.
Can I just say something, though? In terms of when I will cite something like that, it's because you don't actually, in a debate, rely on citations. They support your argument. Now, I'm incredibly lazy. I'm in a sofa with my feet up at the moment, and I've not got anything. My keyboard's it's on charge, and I'm basically lazy. So what I would rather or prefer to do is just win the argument without necessarily using any citations, because they're not even required. Some people will just give you a citation. The dude 2 days ago, I think that's going out tonight on the second channel. Subscribe today to Nathan Oakley if you want to watch Uncut and After Show. But the dude came in and he's like, I've got a citation. Irony of ironies, after Arwin, as he's picked up on a little trick I've been using and decided to become the authority on Arwinian gravity. And he's like, I am the citation. It's like, perfect, this is ace. Because the guy then provides Einstein, and he's like, I've got citation for it. It's like, yeah, just because he's written it down doesn't make it reality any more than Darwin writing it down making it reality. So citations in those regards, people rely on them like they actually prove your argument. And it's the other way around. Citations support your argument, but your argument is what's actually being challenged, not the citation. So when someone says, I'll just read this Google wiki, whatever I've got, it's like, no, I'm not going to read it. Give me what the argument is. If you're claiming science from wiki, give me the dependent and independent variable. I'm not going to read through your wiki citation again because I'm totally lazy. Read it out to me. Tell me what I need to know about what you're claiming, because I don't really care about the citations half the time. I can't even be bothered to read them, let alone garner them and give them. I'd rather win the argument.
Right. But in this discussion, it matters because most of us aren't scientists or astrophysicists. So when we're talking to the Globers and like the people that are watching, they need support from someone that actually is a scientist or an astrophysicist. So
I know. I get it.
Citations help to offer support.
I understand.
I just posted it.
No, I get it. It's strengthened. It supports your argument. Well, I know what supports means, but I'm just lazy. It doesn't. I don't care that they want it to. I don't care if they believe me. So if someone in the chat now says, "I don't think Richard Feynman said that," I don't care. Yeah, right. Oh well, I don't care. Sorry, I shouldn't have that attitude. I know, but I don't care.
I don't care either.
Nathan, I just posted it in Master B for Babs.
I saw. Do you want me to put it up?
No, I don't care.
Oh, perfect. Thank you, 10th. Make my point for me.
Well, what makes Feynman an authority?
Not in Master B.
Oh, excellent question, Arwin. Sorry, don't rumpus, Arwin. Can you say that again, Arwin?
What makes Feynman an authority on these things anyway? You know? He's done a lot of experimentation. He figured out a lot about quantum mechanics, and he was absolutely a mathematics master. But what makes him then an authority on these type of statements? Like, if he disagreed with somebody about something, why does that make anything true? It seems like it's all grounded in this idea of peer review, and that if enough, the consensus type of agreeing.
Well, the same could be said, Arwen, the same could be said about Newton not saying what he's, as people test Newton saying, and find out that 207 years later, somebody else attributed something to Newton.
Right. Well, in that sense, you should take care that if you're going to use Feynman's concepts and theories from his works, you should, of course, not take them out of context. So in relation to Feynman's work, of course, what he said is very important.
Not necessarily.
But other than that, just because this person agrees or disagrees with something out there does not make that true. Right. It's more a consensus-based type of argument.
Correct. Anyway, someone going to read this? If not, it's just about legible and this font size. If no one else wants to read it. No, fine, I'll read it. The discovery of quantum mechanics first, and then the behaviour of light, and then in the behaviour of matter, finally culminating in 1926 with a full equation of quantum mechanics which told us that the laws of motion of Newton were not right and had to be modified with other laws which are quantum laws of motion. Richard Feynman.
Are quantum laws of motion related to bendy space-time?
No.
Is there any way to summarize what the big differences are between his quantum laws of motions and the regular laws of motions from Newton?
They're not his quantum laws of motion. They're not Feynman's. These are based on scientific experimentation. That's where you're getting these.
Hello, everyone. Hey, Nathan. I almost said hey, Arwen. Sorry.
Hey, Brian. I didn't
Hey,
hear
Arwen,
that.
anyway.
Oh.
Hello. We're still in the middle of housekeeping, by the way.
Could I say something about the Feynman thing there?
Sure.
I think it's more to do with the fact that he noticed that, and I'm not sure why, but I think I could be wrong here, so I could be totally corrected by Kiwi. But I think it's more to do with the fact that he noticed that the Newton's laws of motion weren't correct, were not right when it came to smaller things. So kind of if things aren't correct with the smaller things, then they can't be correct with bigger things. It's something to do with this small and big. It's like you can't have different for small and big, something like that.
How have you got your mic doing that? So it's like automatically muting you. That's clever.
Is it doing that? Is it?
Yeah, so when you're not talking, it just pops you back on mute automatically. Anyway, moving on with housekeeping. Any evidence of the R value, Earth radius?
Oh, it's up for grabs. It's flexible. They're still trying to refigure it out, like what the entire universe is folded around this now changing R value doesn't match anymore.
Still saying the horizon's refracted. They're still looking at the oil rigs. They are just not getting black rocket.
Right.
Yeah, I say 8 more months, probably. Maybe longer for some people. But yeah, as long as we understand it. Obviously, it's going to defeat any claim of a curve calculator based with R values at its centre. You know, talking of centres, any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
Oh, well, Adam found a really good animation to show it how it's supposed to be.
Yeah, it's in my intro.
Yeah.
Can't be better than Nathan. That was outstanding.
Shout out to Adam for the intro. He got one on the pre-show, but as we're live now, so the new intro that you saw today was made by Adam. So woohoo! Shout out to Adam Meakin of Iron Rail Media for his fantastic editing skills.
Yeah.
I said to Arwen earlier, I'm world-class plagiarist.
Any evidence that you can have gas pressure without the necessary antecedent of a container to press upon? For all the fundamentalist religious zealots who believe the sky is a vacuum called outer space.
I would like to see it demonstrated here on Earth.
I didn't hear you. You're a bit too quiet, Neil. Say that again.
I said I would like to see it demonstrated if they can do it.
No, you can't. It's a necessary antecedent.
Is a cup a container?
Yes, a cup is a container.
Is a gas tank a container?
Yes, Alwyn. A gas tank is a container.
Not according to Zanuck.
Hello?
Hello, individual one.
Hello?
Hello.
Can you guys hear me okay?
Yeah, loud and clear. Well,
How's
loud.
it going? How's it going?
It's going very well. Just finished the housekeeping questions. Thank you for asking. How's it going for you?
Yeah, you said, yeah, I'm doing pretty good. But I'm trying to understand this topic right here. This guy being a vacuum and stuff like that. Now, it's claimed that water boils at high altitudes. Is that true?
Yeah.
Right.
What
When gas
causes the water
gas pressure decreases,
Well,
then
Let me
it
ask
will
his question.
evaporate.
Hold on, Owen. He hasn't asked his question yet. Go ahead, mate.
Okay, so the absence of pressure causes water to boil?
No, it will cause it to boil at a lower temperature.
Okay. Well, why does it boil at high altitudes? That's confusing.
What's boiling?
water
I mean,
turning
the
into a
claim
gas.
is, I didn't verify this stuff now. The
It's just
claim
he's
is that
leading
water
you.
boils at high altitude.
Sure, he's leading you. So he's asked you what is boiling. It's water liquid form turning into water gas form.
It's a phase transition, what we're witnessing. So part of the variables within that phase transition, along with temperature, is also the pressure the atmosphere creates on the surface where the phase transition is going to occur. And if there's less pushing down, rebounding those molecules that are trying to escape from the surface, then the rate at which they can escape or boil, as we observe it, is lowered. Less resistance. That makes sense.
Yeah, better than I could have done. Thank you,
Thank
Adam.
you.
Is a somber moment of reflection now, or what?
Excuse me?
I think he was under the impression that water by its own, the higher you go, will boil.
Well, in a way, that's part of the assertion, isn't it? Because they've got to transition from pressure to vacuum, and therefore, if you've got that as your paradigm, then yeah, you go up high enough with a cup of water, and eventually it'll just boil of its own volition when you reach a sky vacuum. Now, that assertion is debunked by not having a container to form the pressure in the first place for it to transition through to achieve vacuum at the top. In fact, that's in violation of a natural law, the second law of thermodynamics. But I don't know if that's ever been asserted. I've never heard that asserted or seen it written down. But this guy's natural logical progression in terms of his question does actually make a lot of sense.
You need a container for a vacuum too.
Yes, indeed.
Can Adam summarize what he said again?
Yeah. So when we state a boiling point of water, within that there are certain assumptions, and those assumptions tend to be that it's pure water, because putting other things into it will affect freezing and melting point, salinity, for example. So there are lots of factors that affect the way in which phase transition occurs, and we make these statements that it's at standard temperature and pressure, and they're two biggest variables. But we're talking about temperature, obviously we understand, and that's when we go up the mountain and it boils. That phase transition we notice is happening at a lower temperature, and the two are inversely proportional, temperature and pressure, with regards to this. So as we go up and the pressure decreases, there's less of a requirement of energy input to generate a phase transition, and that's because there's less interference at the surface where the phase transition's occurring.
So what you're saying is, as you're lower, you've got more gas particles bashing into the water, the liquid state, and therefore if something's about to release, i.e. change from being bonded to being unbonded, and it happens to be bashed by a gas particle, then that phase transition may not occur. Whereas as you go up, there's less likelihood that the gas particles are going to bombard it at the point of phase transition, therefore a higher likelihood of phase transition will occur if there's less gas bashing into the water state.
Yeah, put simply, but hopefully that gives you a picture of how the pressure's playing a role.
Okay.
Cool.
I still got more research to do on this stuff. Kind of like going on, but I'll get there.
Adam, are you saying that water wants to become gas, but it can't at surface level due to the amount of pressure we have.
So on a molecular level, water's always doing this. It's called what's called the latent heat of vaporization. So there's always water leaving the surface and coming back during that phase transition, because there's, on an individual molecule level, there's enough energy for that to happen. When you're seeing it boiling, you're seeing loads of it trying to leave at the same time. That's why, yeah.
Excellent. So it is so precise that only the exact adequate amount of water leaves. Like, I mean, due to the, let's say, surface pressure we have, a constant pressure, due to this constant pressure at this particular amount of pressure, it allows only the absolute adequate amount of water to become gas.
I suppose the way in reverse is a hot cup of tea. You think about your hot cup of tea, all you're doing there is changing the temperature of the cup of tea. It's slowly getting lower and lower, and you'll see less and less vapor coming off the tea. But even when your tea's stone cold, if you leave it there long enough, it'll all evaporate away, won't it?
Yes, exactly.
It won't boil off. Boiling is just loads of that happening all at once. Loads of the molecules trying to do it, all of them fighting, trying to get away at the same time.
And when that stuff starts evaporating off, what direction does it go, Adam?
Well, it becomes subject to gas law once it leaves the surface. So
Gas law. That would mean it would expand in every direction.
yeah. Or if obviously it goes back down, it becomes reabsorbed in most cases. But once it's liberated, yeah. So that's any of those directions away from the surface, it will go. But all of those directions away from the surface do have a positive component on the z-axis, i.e. they go up, yeah. To leave the surface, it has to have a positive.
Hold on. Don't they go down, go boom, boom?
No down, boom, boom.
No, mostly
I
down.
want to say something.
No. All of that leave and liberate have to go up, don't they? To leave the surface.
Hold on, let's just get clarity. Mostly down?
No, none down at all initially. No down at all. No down, boom, boom.
But mostly
Up,
down.
so up and away.
All up.
Yeah, that's the thing that I was curious about.
Oh, no, we got a nibble. Hold on, Adam. We got a nibble. Go ahead, Babs.
Yeah, I gotta say this right now before I lose this point. Yeah, they say that most things go down, but our answer to that is that we observe equilibrium. Everything we observe is ordered in equilibrium, and the only things that are moving randomly are gases. But at a fundamental, like micro level, liquids and solids are also randomly moving. But the question is, why is equilibrium down? Like, why is it that there's a tendency for most objects that have mass to be down?
Can I try
in a state of equilibrium?
Sure, I'll try and answer that. I think because the idea of equilibrium in the system that we are in is complete folly. So the word that you would be better substituting for equilibrium is balance. So when you've got Adam describing, who's rustling in G+. Anyway, when you've got Adam describing like water having a single molecule be liberated into a gas state without being at 100 degrees at sea level centigrade, well, that is part of the balance that we experience. Everything's in a harmony as opposed to in equilibrium. So we're never achieving an equilibrium in that regard. There's always a certain amount of entropy, and it's kind of the reason or the necessity that the entropy laws are described with isolated systems, because of that constant flux, that slight imbalance, if you like, which isn't achieving equilibrium. Entropy or change is always occurring. So therefore, to describe this simplistically, you have got to kind of exclude all other influential sources to describe it simplistically. Otherwise, you end up with what I've just given you, which is like, 30 seconds diatribe, just to explain that things change, Well, yeah, things change. Well, that's like 2 words to sum up the entropy law, pretty much. You know, so to describe equilibrium is kind of wrong. Does that make sense?
Right. I agree with you that entropy is always taking place. But the question is that when we're observing specific states of matter, like liquids and solids, for example, why is it that when they're in a state of equilibrium, they're down? Why is equilibrium down?
Well, number one, that's not the
That is
case.
the question.
Number one, it's not. It's up for some things relative to their medium, depending on the medium. It's medium specific. Anyway, the other thing is you're wrong on another front. So let's say you've got a perfectly static puddle and it's isolated in every regard from any sort of heat exchange. Well, it's still not in equilibrium because the thing is moving at high velocity, even though it's bonded. It's still very much moving, even when it looks completely still. Now, you go down another level to solids, and they do the same thing. They're never static. So nothing's in equilibrium. And you can't reach absolute zero, which is to say that nothing's moving. That can't be achieved. So to say equilibrium is almost like saying you can achieve rest at some stage, and nothing's ever at rest. Everything's always in flux, changing, moving. That's how life is. And all we see is sometimes a very tranquil harmony or a tranquil balance. In other words, something in fall arrest when it's reached the bottom of the ocean, for example. But that's not to say that the ocean floor can't fall away and there's another density level below that it could just slip into, like a rock can slip off a cliff when it seems to be perfectly tranquil and in fall arrest. So everything, even when it seems to be static, you can go down another level and say, well, look at all this movement. Even in the rock itself, it's not static. It's got a certain amount of vibration and movement.
Right. At a fundamental micro level, everything is moving. But the difference is the forces between the molecules, like the intermolecular forces, is what make solids what they are and liquids what they are and gases what they are. That's the difference that I've noticed so far. But the question still remains that why is it that solids and liquid...
Go on, go with your question. The question is, why do liquids and solids what?
Well, why is it that solids and liquids are on the ground? Why do they stay on the ground? Why do they have a tendency to be...
Can I answer something there for Bob?
Answer than the medium they're in.
Hold on.
It's-
Adam, hold on.
Babs,
Adam tried to respond first, so go ahead, Adam.
The first point was in just to make with regards to something like glass. In response to what you were saying about things are at the atomic level still moving. So even glass, which has got some components, will settle. So if you go and look at 100-year-old glass, it will be slightly thicker at the bottom than it is at the top, and that's due to relative density. Even in solids, ordering slowly at a very slow rate. I say it takes hundreds of years, but it's been noticed. So it does happen in solids, but entropy still applies, but at such a slowed rate because the relative density differential is so small, but it's still applied.
No, you're cheating, Adam. Glass is technically not a solid. It's technically a liquid.
Fair enough, by true description, yeah. But it's an example of something we consider a solid.
Yeah, hey, pressure, when something cannot maneuver, it will still exert pressure. Like I've pondered upon, even if you put an anvil in the middle of a mercury bath, it may float in it, as it were, because it is kind of in equilibrium with its surrounding, but it's also going to add its pressure pretty much in all directions then, and that will be passed on to the mercury and to the walls of that container it is in.
I like that.
Why does matter arrange itself in that manner? Why is it that the denser objects are at the bottom and the less dense at the top? Why does that order stay consistent?
That's
the way it is.
Isn't that almost like asking why does entropy happen?
Kind of. So this effect so Dr. John D, Quantum Eraser, myself, Sleeping Warrior, and I believe Adam as well, all had probably a week-long discussion on this and came to the conclusion that the description is a second-order effect of entropy. So it's not like you can pin it onto something and establish the cause. It's a second order effect of entropy. So initially I was like, this is entropy. And Dr. John Dee and Quantum Eraser were like, no, it's not entropy, but let's figure out what it is. And then, like I say, there was about a week of discussion on it. It's a second order effect of entropy, if you want to describe it that way. I just wanted to throw something in before we go off on a complete segue, though. So as this to blow your mind, so I like Arwin's description, but this is another similar thing, right? So what about a liquid that flows uphill? So silicon flows upwards. So if you can check this for yourself. If you've got a silicon seal anywhere in your house, like on a bathroom seal or a shower, something like that, go and check out the silicon. And what you will notice is it's worked its way... Arwin. It's worked its way up the glass. So the older the silicon, the more you'll see that the liquid has actually progressed upwards, worked its way up your tile or up your glass of your shower. So silicon flows uphill. How's that to blow your mind?
That's surface tension.
No, isn't it?
Babs,
Isn't that
tell Babs this,
gas?
Arwen?
Isn't that because of just a gas that is part of the solution of it? Isn't it?
Mostly down.
No, that has to do with the liquid being attracted to the walls of the container.
No, it's because gravity's working against buoyancy and mostly down go boom boom. That's what I'm going to say.
Ryan, ask your
you know the
question.
way
No, when you see a concave meniscus in
moment.
something that's in a container, that's because the liquid is being attracted to the walls of the container.
So you're saying
Babs,
that...
remember
Hold on, Brian. So you're saying that essentially the silicon is forming a meniscus. What? Hold on.
Oh shit, I was muted. Yeah, the silicon is forming a meniscus.
So you can have a massive silicon meniscus then. So if you had a pool, if I got a plate with a little indent in the bottom of it, and I covered the surface till it filled up till the first lip with silicon, you're saying that it would just work its way up into a big concave shape and work its way up to the top edge of the plate?
We wouldn't know until we perform the experiment.
Not an
Everything is
experiment.
just hypothetical.
Oh, someone kick him out.
Oops.
Observation.
I mean, we haven't done the experiment, so this is all just hypothetical right now.
This isn't an experiment. This is just merely observing potentially a phenomena in what silicon does.
Right. If it happens on a micro level in a test tube, then yeah, it would happen on a macro level as well.
So you could have literally, you could fill a potentially a swimming pool with silicon and then watch it turn into a concave shape. Amazing.
Yeah, I mean, not as dramatically as you're defining it right now. Probably just like on the edges, you would notice some of the silicon being attracted to the edges of the... I mean, it also has to do with the materials that are being used. If you're looking at silicon in a test tube, that's glass in comparison to a swimming pool that probably has like ceramic or concrete. So it's you have to consider the materials that are being used as well.
Sure. The reason it's fascinating is because obviously when you look at silicon, most people will touch it and feel it's fairly solid nature and not appreciate what it's actually doing when it's working its way up your glass of your shower, or in this instance forming a concave, sort of like a lens shape, I would imagine, depending on how severe it would be towards the centre. And I think, visualising this, how it may actually appear, instead of just having it like with water, you've got a tiny little edge that works its way up. Well, it might be that it works its way further down, is my point. In other words, if you end up with an inch meniscus, that's going to be quite dramatic, right? That's going to form like almost a lens. I don't know, I'm just speculating.
Right, this is all just speculation.
Abs, just to answer your question a while ago, just before we get too far away from it. When you asked why does solids and liquids go down and gases go up kind of thing, that's not correct. You have to use air as the common denominator. All things that are more dense than air will go down. All things go down through it. All things that are less dense than air will go up through it. But the things going down through it also include other gases that are more dense. So it's all about density. So other
Okay,
gases
but
that are more
if we're
dense than air will
defining,
go down.
Hold on, Babs. Just say that again. It's all about what? Because that's the most crucial bit.
Density. It's all about the density of whatever the matter is.
Precisely. So relative density is like adding a descriptor to what is ultimately summarized with one word. It's all about the density. Now you're putting a caveat on in terms of the density of whatever you're comparing in the medium of air. So the relative bit is removed because you're just saying, well, this is all comparable to what happens in air. You change the medium, all the rules change.
okay, it matters because the defining point here is if we're really conducting science and we're following the scientific method, we're gonna want to know what the real cause of this phenomenon is. So far, the cause has been stated as density, but that still doesn't explain why things order themselves in that manner. You can't just say that density is the cause of what we're seeing, because what's causing things to be ordered, you know, in the way that they're ordered?
You
You know,
can.
that question
No, you can
still
answer
hasn't
it.
been
No,
answered. So density
can.
can't be the cause.
No, you can.
There's something else that's causing it.
You can assert that. The density is the cause. You can assert that and verify it. It's been sleeping where I've verified it. You go and check him out with his egg and his salt. It's really simple to do. You can do it yourself. Put a bit of salt with an egg. Watch the egg rise because the density of the water increases. So you can easily demonstrate that's the case. But when you get down to, well, what causes the alignment? Well, then you're into where I described it, or I'm taking credit for what is a discussion that I had very little part of between Dr. John Dee and Quantum Eraser. And it's in terms of what will give you that cause. Well, you're never going to achieve it. It's like trying to, I don't know who said it earlier to give him credit, but it's like trying to say what's the cause of entropy. Well, this is a second order effect of entropy in terms of trying to establish what causes the overall effect, what causes the density alignment to take its shape. Well, no, the way you can describe how things move through their relative densities, in that case water, or in this case air, is just with one word, density. That is what causes that. And you can verify it with science. Check out All Hail Sleeping Warrior the Scientist.
Real quick, Babs, what's your name in Discord right now, bro? So I can send you this thing. Hello?
You chopping up. His name's Pope, something Space Pope. He's chopping up. I don't know if you want to drop and rejoin.
All right.
Chopping up,
Thanks.
Babs.
That's all I need. Thank you.
I think he's sending you something, if you can still hear us, Space Pope, but you're chopping up and we can't hear what you're saying anymore. You've gone all crappy. Not you, Chocolate. Chocolate's just dropped and rejoined thinking I was talking to him.
No, I actually hit the end button by accident.
Oh, okay. No, I thought I made it clear. Yeah, Space Pope was dropping.
Nathan,
Well-
can I introduce another factor that I was thinking while everyone was talking about the subject?
Yeah, by all means.
Okay, so information and the creator and the way things behave. It's if you believe in the creator, if you accept the fact that there has to be a creator, then the creator has put information into things. Like, why would he make an apple go up? It needs to fall so I could eat it. So, you know what I'm saying? It's like it's ordered. Everything is ordered to work the way it is, and we get to a place where we're saying, why? Why is it working that way? And sometimes we bang our heads against because we can't figure out the next why. But
Yeah. Can you hear me now? Mic check.
Loud and clear.
yeah.
Right. Yeah, so that still doesn't answer the question, though. Like, I mean, I understand what you're saying, that yes, density does cause things to be ordered in that way.
I'll answer the question
though,
for you.
why are things
I have
ordered?
the answer, Babs.
Hold on.
Go
on, Brian.
Thank you, Nathan. The answer is,
why
Babs,
are denser things at
the answer, Babs, is that if it didn't happen that way, then we wouldn't exist. That's the actual answer. We won't find out what that is. It's search for 100 years. You're going to have your work cut out and find out what that is.
Yeah, agreed.
That still doesn't answer the question, Brian.
You're right. You're not
Well,
going to either. That's what he's saying. You
what are you
won't
trying to answer
this.
the question for? Sorry, Nathan.
He's right. You're not going to establish this as a cause. I'm sorry.
Why is that not of importance? Don't we need to know why things are ordered in that way?
Like I say, it's trying to establish why entropy occurs. Why does change occur? Well, that's going to be the ultimate question. And like with any natural law, you're not going to find the cause for it. If you did find the cause for it, it would cease to be a natural law.
I see, right. So what you're saying is it's impossible, really?
I think establishment of the cause of entropy, or in this instance, a second order effect of entropy, it's going to be impossible to establish the cause of it through science. Yes.
I mean, people have made attempts, be it... Hold on. People have made attempts, be it fallacious. We have seen the Cavendish experiment and all these attempts that have been made to explain what we're observing and explain the cause for it. So I think it is of importance. So, but what you're saying is that these things can never be understood. We're never going to know why these things are happening.
Sure.
Really?
If I give you a question within the law, you tell me how difficult this is to answer. Why does heat flow to cold always?
Why does what, sorry?
Hot flow to cold. Why does that always happen? What's the cause of hot going to cold?
Because matter always seeks equilibrium.
What equilibrium? Didn't we go over this? Change is always occurring, though, isn't it? Change is always occurring. So we're going around in a circle where we try and establish what's the cause of this change. What's the cause of entropy? Well, as I say, you won't ever establish the cause, because if you did, it would cease to be a law.
The cause is the system that we live in. We're constantly being subjected to energy.
Let me just stop you.
The sun.
So hold on. So the system we live in, so what, that be nature? Yeah, this would be a law of nature. It's just because that's how nature is. It's just a description. Any law of nature is just a description of how things are.
Right. That's just how things work. We don't know how they work, but that's just how they work.
Abs, the reason that we don't like the actual cause of entropy and the cause of why things order themselves due to density is and has to be, right? Through logic, it has to be because we have a creator. That is the reason.
No, that's two steps away. You can make that, but just not with one step like you've just done. You can come to that with a couple of more steps in between, but no, not a direct. It's not a direct. Nature is in beautiful harmony, but does that mean that we must have a creator? Well, no, I wouldn't say so. Energy cannot be created or destroyed. So all of the things we've discussed here, all these phase changes, are merely change occurring. Well, if that is a inviolable law of nature, and it is the first law of thermodynamics, then where did it all come from? Because it can't be created within the system. That's impossible. Ergo, there is a creator. Now that is a step to the creator, not, well, we've got a beautiful balance. Isn't nature lovely? Therefore, creator. I hear that all the time, and I'm like, that's so ham-handed. No, I'm not having that. Sorry, Brian. Slap, slap, slap.
All right.
Yeah, the question of where everything came from does bring into question that there must be a creator, because where did everything come from? Like, things don't just randomly appear out of nowhere.
Exactly.
Unless you're a glober.
Exactly. You can go from nature and how it works to questions about how natural laws come into existence, to how does everything come into existence, to the ontological primitives, to God. So it's not just as easy as saying, well, nature proves there's a God. And like I say, I hear people say it all the time. It's like, mumble, mumble. You know what I mean?
Right.
I don't think nature proves there's a God. I think the information proves there's a creator, because I see information. I see creation. There has to be a creator.
Equally as good.
Like you said,
Equally as good. Yeah, you can't have knowledge without a knower. Therefore, there must have been a knower in the first instance. So knowledge proves there's a God. It's just as good. First law of thermodynamics, because then you undo the assertion within the paradigm that they currently have as well. Everything came from nothing, Big Bang. No, it didn't. That violates the first law of thermodynamics. So what are you left with? If it can't be created within the system, it must have been created by an external source. That's it. End of.
But we, as using intellect in that we are part of that system. We rely on that system to exist.
Yeah,
It
you're
doesn't
halfway
rely
there.
on us.
Nah.
Sorry.
Well, it's just you're halfway there again. So, knowledge, that's the chocolate's got it in one, because as soon as you start to assert knowledge, not only can you back it up with scientific actual validity that is verifiable, that you require information to have a second participant, somebody who's sentient, a knower. You can't have information without a knower. So how does it all start? Well, you can't have anything to begin with unless you've got a knower. Well, what's a knower? Well, if you haven't got anything other than the knower, you've only got a God. That's all that means. Information is that it's just chocolate's taken that route much more efficiently than I have.
Right.
Yeah, I know.
The quantum eraser talks about the infinite regress fallacy when defining a creator. But where did the creator come from? That still applies.
Right.
The creator
did this
couldn't have
before.
just come out of
I love it.
nowhere.
I love
we
how
did this before, Babs.
I was going to say he's
Why?
asserted the fallacy and then immediately utilised it. So I know there's a fallacy about who created the creator's creator. But who created the creator of the creator's creator's creator? But who created that creator's creator? And he's creating the creator's creator's creator? And so it goes on infinitely. It's an infinite regress fallacy. Beyond the point that you can prove that there must have been an external source, then that's the full stop, because there is an external force. Now, you're never going to get onto the level of seeing that external creator to ask the question, were you created initially? Well, no, if he was, then there was still the same answer to your original question, which is to say, was there an external force creating everything? Well, there could be 20 steps in between that and an ultimate creator, but it still leaves you with an ultimate creator. You just insert the infinite regress fallacy because you can never have an answer, and that never gives you an answer to the question in the first place. That's why it's a fallacy.
That would mean that the creator exists in an area, a region that doesn't have the same laws that we have here.
Absolutely. That
creator
it cannot be any other way.
Yeah.
If you're a game programmer, you're not subject to the laws and rules that you impose on your program. And if we have a creator, which we absolutely must, then that creator isn't going to be subject to the rules and laws of that which he creates. So no, there's an external place that you're never going to experience because it's ethereal beyond your physical matter. And that area is going to be potentially subject to laws I'm never going to know. But the laws we're subject to absolutely will not be, the inventor of the rules and laws isn't going to be subject to his own inventions and creations in those regards. That makes no sense. In the same way, a game programmer is suddenly not going to have to deal with how you have to chop up a Minecraft block because he's imposed those laws on that program. Anyway, with that, I'm going to say a huge, massive, enormous thank you to all of you tuned in live on the Nathan Oakley 1980 live stream for hopefully smashing the super chat, liking, commenting, sharing, subscribing, and all that good stuff. If you are watching on the Nathan Oakley premiering stream, then stay tuned as there will be an after show to follow. Massive thank you to today's Discord and G Plus panels for making the live show possible. Once again, stay tuned if you're watching on the premiering stream. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!